Okay, this is a quick demo of the LRA Saga, and it involves two services, the transfer service and the account service. The transfer service is taking requests to transfer money from one account to another, and then the account service has the withdrawal and deposit methods that the transfer account calls. First thing we'll do is look at the balances for account 66 and account 67. We see they are both the same amount, $10,800. We will go ahead and initiate a transfer. So let's do a transfer from account 66 to account 67 for $100. Okay, we will see that the transfer status is withdrawal succeeded and the deposit succeeded. So if we check out the balances now, we'll see 100 came out of 66 and 100 went into 67. So let's look at the logs for that. We see the transfer service got the request. It started an LRA, and this is the LRA transfer ID. That's the same ID as used. The LRA ID is used as the transfer ID. We see the withdrawal account 66 for the amount, and that the withdrawal succeeded, the withdrawal call succeeded to the account service. And then likewise for deposit call succeeded. So both succeeded, withdrawal and deposit. That's the message we saw. And then, so therefore the action will be to confirm. And we see that we received a confirm for the transfer. Now, if we look over at the account, we'll see the calls. First, we see the calls to query the account balances here for 66, 67. We see the withdrawal request for account 66. We see that amount reduced and journaled. And again, after all of this, I will show the source code. Then we see the second call for a deposit of the $100 into account 66. And then we see that both were successful. So we got the call to complete. So the transfer service called the coordinator and said to confirm the transaction and complete it. And then the coordinator called the complete methods on the account withdrawal and the account deposit methods for account 66 and 67. They went through okay, and then likewise the after LRA calls came from the coordinator and they went fine, and then we checked the balance again. Okay, let's go ahead and do a compensate scenario where we try to withdraw more funds than there are. So this time we get the insufficient funds that we'd expect because account 66 did not have $100,000. And so we come over here and we see, similar in transfer, except that because of the insufficient funds, the action is cancel. And so again, calls cancel on the coordinator. The coordinator calls the corresponding calls on the account withdrawal and deposit service endpoints. So we see insufficient funds, and then the compensate method is called. Okay. And after LRA as well. Okay. And we could also do a scenario where, the account doesn't exist. So account does not exist, and we'll see the same thing. We'll see the cancel and the compensate calls. Okay. So let's go ahead and look at the source. Again, we have the transfer and the account services. Look at the transfer service first. It's the simpler of the two. So the main logic is in the transfer service here. These are just the URIs they're hard coded right now, so we just need to get them from the environment. This is the transfer method that was called by curl. It comes in and makes a withdrawal, and if that withdrawal is successful, it goes ahead and makes it a deposit. This LRA requires new is what triggers the LRA to be created, triggers the call to the coordinator to begin the LRA, and brings back this LRAD that we're using also as the journal ID. Then what we see on these withdrawal and deposit methods, which are pretty much the same, we're passing that account ID and the account amount to the withdrawal, and we are getting the LRAD and adding that as a header. Okay, now this is in the code where we are going to move this out into interceptor, and so that'll be an interceptor class, and so we can take it out, but it's only this addition of this header, but that's what we're doing to propagate that LRA ID. Now let me go into the account service and then come back to this transfer service to explain how we're actually doing the cancel or confirm, because that's a bit unique and different from JTA. But first, let's go to the account side of the LRA flow. So on the account side, we have the account table itself and then the journal. And so this account is just the basic account information you would expect, the ID and the balance, etc. And then this journal, as the documentation says, actually serves a few different purposes. So it's a ledger for the transfer operations. So it's saying how much to deposit, how much to withdraw. It's also a journal for tracking changes made in an LRA. So changes are tracked in this journal, and then if something goes wrong, in particular in the scenario where if something goes wrong, the journal is read, and the changes can be compensated. And then likewise for complete, the journal will be read, and whatever changes need to be made in the success case will be made based on this journal. So this sits outside the actual account table, and this is what's used, basically in not to go too much into it, but in JTA and XA, you have your built-in in-doubt tables in the database. In LRA and Sagas, you need to keep track of that information yourself, and that's what this journal is, okay? And then it's also a store for the actual LRA state. So the participants in an LRA need to keep track of their state and report it to the coordinator when it asks, and for its own internal bookkeeping, okay? So it's doing three things. Now, for the ledger, the actual, amounts that are being deposited and withdrawn, that could be a separate table, and it could be a blockchain table. But again, for this, we're just combining the three just to make it simple. We're just using this one journal model. And then the repos, just what you'd expect as far as find bys. And then the services themselves. The admin service is just doing the find bys for the accounts and creating the account. Okay, now if we go over to the withdrawal service, the transfer service calls the withdrawal service and propagates the LRAD, as I mentioned, because the LRAD value is mandatory if it's not called within an LRA context. In other words, if this header doesn't exist, an exception will be thrown. So we know that it's being executed within this LRA, within this Saga. Okay, so what we do, just going through this fairly quickly, we check, we get the account that's mentioned, which is the from account. We make sure that it exists. If not, we throw that doesn't exist method we mentioned, and we make sure that there are enough funds to do this withdrawal amount, or we throw that insufficient funds that we saw. Next, we go ahead and we reduce that amount in the account, but we also write a log saying that we did this withdrawal, okay? And so just jumping ahead, if everything completes fine, we just set the journal to, say that the LRA completed, and that's it, okay? But if we have something goes wrong during this transfer process, the compensate method will, get the journal entry, set the status to compensating while it puts the money back into the bank account. Okay. And then goes ahead and, marks the LRA status in the journal as compensated and returns it. Okay. Now that's just the opposite behavior in the deposit service. In the deposit service, when we get the deposit, we only write the journal entry for the deposit. We don't actually put the money into the account. And that's, for consistency reasons. We don't want to have money that's visible in one account that has not actually been removed in another account. So in the deposit case, we just journal the deposit. And if it's successful, then we go ahead and put the money into the account and, mark the journal and the LRA state and everything. And in the case of compensate, we don't do anything because we didn't actually take the money out of the account. We just update the journal accordingly. Okay. Now this, the status method is just returning the status. And this is just getting the status from that journal that we've been writing along the process here. Okay. And, it's in these different participant states as far as active or compensating, failed to compensate, things like that. And this is used by the coordinator to make sure that recovery is idempotent. So if a coordinator has called complete or compensate and hasn't received a response, it will call status, and the participant will say, oh, I'm in the middle of compensating, in the middle of completing, whatever the case may be. And so if it says that, or if it says that it was compensated or whatever, the coordinator knows not to make another call to complete or compensate. Okay, so that's the idempotent mechanism. And then there's this after LRA, and this is for cleaning up the logs. Okay, or whatever other activity in the after. So both of these services are just calling this helper data access object, and this is doing actually all the repo work. Okay. Now let's go back to the transfer service, or I should, while I'm here, let me go into the way that we're making it so that we can use both JAX RS and Jersey REST in the same microservice. Okay, so there are two things that are required to do that. One is just to use LRA in the first place with JAX RS is this Jersey config. And here we're registering the JAX RS services. And we're registering them, and we're registering the server side filter. So requests coming into these services are intercepted by this filter. And this is the filter that's, doing all the LRA work I mentioned. The first thing that you need to have JAX RS running in the same server as Spring REST is this property here, which tells the server to forward any unknown values for the JAX RS calls. Okay. The second part that's necessary, and the more important part really, is the simple attribute here, which is the Spring Jersey type. And we're making Jersey a filter, and that's how you can get JAX RS to run in the Spring environment and also have Spring REST. So here, this admin service is using Spring REST. You can see the REST controller, request mapping annotations, and the withdrawal and deposit are using JAX RS, request scope, post, path, etc. Okay. Now, going back to the transfer service, what happens here is, we do the transfer, and if we see that for example, there are enough funds and that the account exists, and we want to either confirm or cancel the transfer activity, these are the methods that are called. Okay, and so what happens here is, again, this is a bit different from JTA. So what we're doing here is we're calling these methods, and the default for LRA is actually end equals true. So if we were to explicitly add this, it would be end equals true. See, that's the default. And what that means is when you exit the method, you end the LRA. You're telling the coordinator to end the LRA either by doing a commit, or I'm sorry, a complete or compensate. So in this case, for process confirm, all we're doing is returning okay, and then it's going to go ahead and do the confirm, okay? If in this case, when we do process cancel, we're saying cancel on the response code okay. And that means if, you can put any code you want here, like a 500 or whatever the case may be. So if we're going to cancel on an okay status, we just return okay here. And so this is actually initiating a cancel, okay? Now, this next part is very unique because most, haven't seen any other examples, of doing this. But if you want the self-contained, in other words, if you want the transfer service to, decide if it should complete or compensate, instead of passing it to the caller, it sees that there's insufficient funds or whatever the case may be, and it wants to do the complete and compensate itself, not make it so that the caller is making those calls. You have to do a little bit of a trick. And again, I haven't seen any examples of this, but this is how you do it. And it may seem a bit odd, but what you're doing is, you're calling these methods, but you're calling them, as I say, in this scenario, in place in the transfer service. And so what's happening is in transfer, we decide if it's going to be, depending on, again, whatever the criteria, if there were insufficient funds, if it's going to be a compensate call or not. And depending on that, we either call this confirm method or the cancel method here. And you'll see that these are annotated with not supported, okay, which is saying it's not going to throw an error if it's called in the context of an LRA in the context of an LRA, but it's going to suspend that LRA. And in other words, it's not going to process the LRA ID in the header. And so whatever you do in these methods is outside of that. So what I do here is they're both not supported. So they're operating outside an LRA ID. And then I call, depending, either the process confirm or process cancel from them. And I'm passing in the LRA ID, which again is the same thing as the transfer ID, to that method, okay? And so it will come into this method. It will import that transfer ID, that LRA ID, and then depending on the return, again, as I just described, it will either, confirm, we'll finish that Saga LRA day or compensate. Okay, so that's a bit unique. I just figured I'd go into this description of it because, I mean, there are no examples out there really that are showing even the journaling and such, let alone that doing the call within the same client like that. So I just wanted to give a complete explanation of everything. I think that's about it. So I'll leave it there and let me know if you have any more questions. Thanks.